All right, this is a video for geometry on the surface area of pyramids and cones, and they're actually very closely related, which is why we're putting them together into one video. We'll start off with a reminder of some terms, look at a couple formulas, and then go through a bunch of examples. So a pyramid is a three-dimensional solid that has a base that could be any sort of a polygon. Square, triangle, pentagon, etc. And its faces tip together and merge at a point called the vertex. Okay, just really what you imagine a pyramid to be. So the vertex is that top point where the faces join. And there's some terms that we need to be able to understand. A regular pyramid is simply a pyramid that has a regular polygon as its base, so a square pyramid or a regular pentagonal pyramid, for example. The slant height is really important as the vertical distance, or the slanted distance, I suppose, that's along the center of a face of a pyramid. Okay, so the pyramid's lateral faces are going to be triangles, and the slant height you can think of as the height of that triangle. And that differs from the interior height of the pyramid. Okay, so really it's important that you understand the difference between height of a pyramid and the slant height of a pyramid. The slant height also, importantly, is not along the lateral edge of a pyramid. Okay, the slant height goes through the middle of one of those triangular faces. Okay, so we're going to be working with slant height quite a bit here. And so that's going to be real important that you really get that. A cone, by the way, is simply a circular pyramid, right? A pyramid with a circular base. And a cone won't have lateral faces. It has sort of one curved face that wraps around the sort of the sides of the pyramid. All right, let me get you a formula for the lateral and total surface areas of a pyramid. So the lateral area of a pyramid is the sum of the areas of these triangular faces, okay? Basically the entire surface area except for the base. And that's the formula that's hard to remember that you want to make sure you really write down and memorize carefully. The formula for the lateral area is equal to 1/2 times the perimeter times L, which is the slant height. Okay, 1/2 times the perimeter times L, which is the slant height. The surface area of the entire perimeter, or of the entire pyramid, excuse me, is simply the lateral area plus the base. Okay, so the base you'll need a variety of tools to try to figure out. In the picture that I'm showing here, the base is simply a square, and that should be easy to find, but the base might be a trapezoid, it might be something different. Okay, the important formula that you really is tricky to memorize is this one. The lateral area is 1/2 times the perimeter times the slant height. Let's do an example here, okay? So here it looks like we have a regular hexagonal pyramid. Okay, this is going to be a little bit of a tricky one, but let's do it carefully, okay? So the lateral area is 1/2 times the perimeter times the slant height. So let's fill in what we know. The perimeter is going to be 6 times 6. Okay, there's 6 sides, each side is 6 inches long, times the slant height of 9. Okay, so let's go ahead and do that multiplication. And we get the lateral area is 162 inches squared. Like everything we do with surface area, keeping track, staying organized, keeping track of your intermediate numbers is really going to be important. Let's find the base area. This looks like a regular hexagon, so remember the formula for that is 1/2 times the apothem times the perimeter. So that's going to be 1/2 times 3√3 times our perimeter of 36. Okay. So this turns into 54√3. I'm going to keep it as an exact answer right now in radical form for now. 54√3 square inches. So our total area is simply the sum of those. 162 plus 54√3 square inches. We could certainly turn this into a decimal approximation by adding those two numbers together and this is approximately 255.53 square inches. Okay, so depending on what the book or the test or your teacher asks for, both of those or either of those are legitimate answers here. All right, a little bit of a real world problem. It looks like we have a square pyramid, and we're wondering what the surface area of that pyramid is. The question isn't explicitly asked here, but I'm going to assume that we don't need to find the surface area of the base of this pyramid. Okay, so any sort of real world application, maybe we're thinking about painting or thinking about the amount of exposed brick on this pyramid, we wouldn't be considering the square base. So let's just find the lateral area of this pyramid. So remember that lateral area is 1/2 times P times the slant height. Okay, and so in this case it's 1/2. Our perimeter is a square base, so it's going to be 30 times 4, but we don't know what the slant height is yet. So we're trying to find that slant height right there. Looks like we'll need to use the Pythagorean theorem. So let me draw this little triangle that we'll be working with. And it looks like we have a height of 36.4. Can you see that the base of that triangle is 15? That's half of the 30. So let's find the slant height, which is L. So 36.4 squared plus 15 squared equals L squared. I'm not going to go through all that work for you. I'll do it just on my calculator. And I get L is approximately 39.37 meters. And that makes realistic sense because it's a bit more than that height. It needs to be longer than the height. It's the hypotenuse of that triangle, but 39.37. So we'll plug that in up here, 39.37. And let's go ahead and get a final surface area or lateral area of that stone pyramid. So the lateral area ends up being 2,362.2 square meters. Okay, that would be the solution right there. Lateral and surface area of a cone are very similar. So the lateral area is 1/2 times P times L, but in this case, P you can think of that as the circumference. And then the surface area is the same, is simply the lateral area plus the base area. Okay, and here the base area is going to be found using the formula for circle. Okay, so 1/2 PL or 1/2 times the circumference times L. And we could simplify that a little bit more, but that actually then would give you two formulas that you sort of need to memorize. I mean, I'll show you that here, but I don't feel like you should have to simplify it. Basically what I'm showing you is that the 1/2 and the 2 cancel out, so we get pi r L. But really what I memorize, what I commit to memory is that 1/2 times the circumference times L, because it applies to the pyramid as well. So let's do an example right here. We have a cone. Looks like we have a slant height of 25, a radius of 15. Let's find the entire surface area of the cone. So the surface area is going to be pi r squared, which is the circular base, plus 1/2 times the circumference times the slant height of 25. And let's plug in what we know. So we have pi times 15 squared plus 1/2 times 2 pi times 15 all times 25. So this turns into 225 pi plus, as I alluded to earlier, those cancel. 15 times 25 is 375. And then we can combine like terms. They're both being multiplied by pi. And so this turns into a nice round exact answer of 600 pi, and that's going to be in square centimeters. Yeah, that's the entire surface area of that cone. As a bit of a real world example though, we'll look at finding the surface area of this conical funnel, and I hope you can imagine that there wouldn't be a circular disc enclosing the funnel. That would be open. So let's find the surface area of that funnel. I think you could also imagine a funnel sort of has an inside and an outside. Let's just find say, the outside. And then we could certainly double that to find sort of the entire area of the funnel that's exposed to the air. But let's just find the lateral area of the cone. So remember, the lateral area of a cone is 1/2 times the circumference or perimeter times L. Okay, so that's 1/2 times 2 pi r times L. So that turns into 1/2 times 2 times pi. The radius here is 40, and L is 45. So we can simplify that down a little bit. And I get an 1800 pi, which is approximately 5,654.87, and that would be in millimeters squared. So that would be the sort of the outside surface area of that funnel. All right, we got through them all. Surface area of pyramids and cones, basically use the identical formula. Just remember one of those formulas. And then you can always simplify down the one for the cone if you need to. All right, and that's a good place to stop.